In this video, we're going to talk about atmospheric pollutants from fuels when we burn them. We're going to talk about global dimming, and we'll talk about acid rain. So, global dimming, it happens because of incomplete combustion of fuels. And it causes health problems for humans, and that's why it's such a big issue. Now, if that's the case, it produces carbon particulates, and these words are really important, okay, and carbon monoxide. Now, what's really important here? Carbon monoxide, toxic, colourless, odourless. So you can't really detect it very well. That's why we have carbon monoxide detectors in houses. Now, really important that you recognise these words all in green because you need to remember them and use them in answers to questions. We also have carbon, which is produced, which causes respiratory problems. And we'll show you this visually in a second. So if we move that out of the way, remember, incomplete combustion of fuels causes carbon particulates and carbon monoxide. You can also get other effects because of impurities in the fuels, but we'll talk about those more in acid rain. So here I am in the lab showing you the Bunsen burner. You can see that the collar on the bottom of the Bunsen burner is completely closed. That's limiting the amount of oxygen in there, which means we get incomplete combustion. If you want to look at a full video on incomplete combustion, it's in Unit 7. So look up Unit 7 and it'll be under combustion there. But the incomplete combustion of the fuels produces carbon particulates and carbon monoxide, okay? And we can show you the carbon that's produced in the next video. So here I am again in the lab, and I'm just heating this gauze over an incomplete combustion flame, and you can see the black. This is the stuff that can go into your lungs if you live in a inner city with lots and lots and lots of pollution. Okay, it's really, really important. This is your carbon that causes those respiratory problems. Now, I was in a hospital once, and I was not there because I was ill, but there because I was on a medical trip, and they showed us a cadaver, which is a body that is used to study medicine, and they showed us the effect of this. And basically it causes your lungs to have a line of this carbon material or material like this in it, and it's not very good for you at all. Now, why does it happen? Well, it happens because of pollution. Pollution happens because of things like cars. That's why we're all moving to, one of the many reasons we're moving to electric cars. Look at that pollution that's coming out the back, and the older the car, the worse the pollution is. So that pollution is coming all the way out the back. And then you can see the pollution then gets breathed in by us. So what happens is it gets taken across and breathed in if you're close to that area. And you can see it going now. And it goes in, and you can see that the lungs are going grey. That's just to show you that this is taking into your lungs, okay, and it can cause future problems and things like that. Respiratory problems is the key answer. Now, where does that happen? It happens really in big cities. So you've got big city here, okay, and you can see that kind of cloud that's smog that's going above there, we used to call it, things like that. But that is full of these particulates and full of these different impurities that have come from burning fuels incompletely or burning the impurities in fuels. And here you have that sitting atop. Now it lowers the temperature of the place affected, blocks the sunlight as well, but it's also the most worst thing is the respiratory problems it causes to the humans that are inhabiting that city. And they have in many, many cities that are like this, they'll have a pollution alert to say how bad it is at any one point, and lots of people in really bad places like this actually use face masks. We're now going to move on to talk about acid rain. We've got a beautiful cloud up here right now which is going to rain on us. Okay, and you can see that rain coming down, and as it comes down it can turn into acid rain. So how can it turn into acid rain? Well, it turns into acid rain in the following ways. In industries and factories and things like that, what we'll have is the burning of fuels, and inside those fuels are impurities. Those impurities get oxidized and they form this dirty cloud here that then dissolves in the clouds that have moisture in. That moisture, that water, reacts with the impurities to form this acid rain. Now we've drawn it as red just to give you a reminder that acid is red when you add universal indicator. When you see this acid rain coming down, or if you're in it, you wouldn't notice it being red. It's just a visual thing. Now, the impurities are usually sulfur or nitrogen. So sulfur or nitrogen. And what they do, they get oxidized in this huge heat, and it happens in car engines as well. So car engines are going to get so hot that the nitrogen and oxygen react to create NOx. It can be NO or NO2 or anything like that. But again, you don't need to know all of that. You just need to know it creates a nitrogen oxide. The sulfur usually comes from coal that's in these power stations. And the power stations then release that gas, that SO2, and that reacts with the water in the clouds. And before you know it, you've got acid rain coming down out of the clouds. So what do you really need to know for the exam? So for the exam, you are going to have to know that you get production of these impurities through oxidation due to this heat in the factories and in the power stations and the cars and such and so forth. And the two things you will make are SO2 and NOx, which could be NO or NO2, for example. You'll have to balance an equation if it needs to be balanced, or make one, for example, on the oxidation of one of the impurities. So we've got sulfur, solid, reacting with the oxygen in the gas, and that solid means it's within the coal, for example. Okay, and then that creates SO2, which is our dirty gas that we saw rising up and then reacting to form this yellowish cloud here. Now that SO2 then reacts with water and becomes acid rain, and that acid rain is a very dilute sulfuric acid. Okay, so SO2 reacts with water to form that sulfuric acid, which is acid rain. And you have to know that it creates that sulfuric acid, but you don't have to know the exact equation to make sulfuric acid. Same thing happens with nitrogen. We've given you an example here. Nitrogen and oxygen can happen, for example, like I said, in car engines, if they're really hot, and it's a really good thing to emphasize here, if they're hot. So it might say, why do you get these impurities? It's because the engine is hot. If the engine is hot, it's hot enough to give the activation energy for these two things to react and make our nitrogen oxides. The nitrogen oxide then reacts with the water in the cloud, creates the nitric acid. That nitric acid then rains down on us and our statues and so forth, and can cause erosion and other problems. But in the next part, what we're going to do is consider some balancing equations and kind of questions related to this. Now we've got our acid rain cloud up there still, and imagine it's raining down acid rain, but it's raining it down on calcium carbonate statues or buildings. Now there's lots of statues made out of calcium carbonate, and over time, slowly they will start to erode. And they can erode with acid rain that is sulfuric acid, or with one that is nitric acid. So what we want to do is do a balanced equation for that reaction of calcium carbonate with nitric acid. So what I'd like you to do is stop the video and try and do that balanced equation, and this one as well. And we'll see whether you can do it. Now it involves you making compounds, ionic compounds, and it involves you knowing what the products are. So we'll start off by writing at the beginning. So what we've got here, we've got calcium carbonate. So we've got calcium carbonate, and the calcium carbonate is being added to nitric acid. So it's about a memory of the nitric acid. So nitric acid is HNO3. We have an arrow, and then we think about what our products are. Well, our products are carbonate plus an acid. Carbonate plus an acid, or metal carbonate plus an acid, is going to equal a salt plus carbon dioxide plus water. So we need to work out what the salt is. Now the salt comes from the metal, and it comes from this NO3 ion here. So the metal is Ca2+, and the ion is NO3-. That's, I'm afraid, just memorising. You have to memorise these things and go to the periodic table and make sure you know them. Two ways of doing this. You can look at the 2 and look at, this is a 1 here. We can draw it as NO3-. Swap the numbers around. That means you have Ca, which has a 1 by it, and then the 2 gets taken down here. That means 2 times the NO3. So there we go. And then all we have to finish it off is, after we've done our salt, we can have our water and we can have our CO2. Okay, so we've got that. Now we need to just balance it. So I'll get a different pen to balance it with. Okay, and then we go going here. How do we balance this? Okay, easiest way to balance it is look at the NO3s. So I've got 2 NO3s. Oh, I've only got 1 NO3 here, so I definitely need to put a 2 there because I need 2 NO3s. Now that means 2 hydrogens. Well, I've got 2 hydrogens. Okay, that means I've got 1 calcium, 1 calcium. I've got 1 carbon, 3 oxygens. So there, I've already counted those oxygens when I did the NO3, so I'll just count these. 1, 2, 3. Okay, that is balanced. Superb. Right, okay, go to the next one. Again, you'll just check if you've done it already, and I'll go through this one a little bit quicker. So this time, we have calcium carbonate again. Okay, so we've got calcium carbonate again, this time sulfuric acid. Okay, so sulfuric acid. Now if it's sulfuric acid, that's the memorised bit that you need to know, and we're going to make our salt again. So our salt is going to be the calcium sulfate, because with acids you get sulfates. With nitric acid you get nitrates, sulfuric acid you get sulfates. Okay, so that's again Ca2 plus, SO4 2 minus. Right, they cancel out because there's 2, 2, so that means CaSO4. Okay, now we've got CaSO4, again we know there's a carbonate, so it's water and carbon dioxide. Okay, so we go water plus CO2, and then we look at balancing it again this time. Do we need to balance it? So we're looking here, right, okay, have we got the right numbers? And if you go very quickly through it, you can see we do have the right numbers, okay? So basically that's the kind of questions you might get to kind of say what erosion happens with acid rain. There's our two types of acid rain, our nitric acid and our sulfuric acid. And you know that comes from impurities of sulfur in coal, and in car engines you've got that high temperature that is forcing the nitrogen and oxygen to react. And it has the following repercussions: erosion through these equations.